Particle physics is the study of the fundamental building blocks of matter and the interactions between them. At its core, it seeks to understand the smallest objects in the universe, the subatomic particles that make up everything we see around us. These particles include quarks, leptons, and gauge bosons, among others. The study of particle physics involves the use of powerful tools like particle accelerators and detectors to explore the properties of these particles and understand their behavior. The building blocks of matter are particles known as quarks and leptons. Quarks are the building blocks of protons and neutrons, which are found in the nuclei of atoms. There are 6 types of quarks: up, down, charm, strange, top, and bottom. Leptons, on the other hand, are particles that do not interact with the strong force that holds quarks together. There are 6 types of leptons: electrons, muons, tau, and their associated neutrinos. Electrons are negatively charged particles that orbit the nucleus of an atom, while muons and tau are heavier versions of electrons that decay into lighter particles after a short time. Particles also interact with each other through 4 fundamental forces: gravity, electromagnetism, the weak force, and the strong force. Gravity is the weakest of the 4 forces and affects all particles with mass. Electromagnetism is the force that causes charged particles to attract or repel each other. The weak force is responsible for the decay of some particles, while the strong force holds the nuclei of atoms together. The study of particle physics involves the use of accelerators, which are machines that accelerate particles to nearly the speed of light. These particles are then collided with each other or with a target, producing a shower of new particles that can be detected and studied. Detectors are used to measure the properties of these particles, such as their energy, mass, and charge. One of the most significant discoveries in particle physics was the Higgs boson, which was first observed at the Large Hadron Collider, LHC, in 2012. The Higgs boson is a particle that is responsible for giving other particles mass. Without the Higgs boson, particles would not have any mass, and the universe as we know it would not exist. Another important concept in particle physics is antimatter, which is the mirror image of matter. Antimatter particles have the same mass as their matter counterparts but have opposite charges. When matter and antimatter particles collide, they annihilate each other, releasing a large amount of energy. The study of antimatter is essential for understanding the behavior of particles and the interactions between them. In addition to the study of particles and their interactions, particle physics has many practical applications. For example, the technology used to create and detect particles can be used in medical imaging and cancer treatment. The development of particle accelerators has also led to advancements in other fields, such as materials science and nuclear energy. In summary, particle physics is the study of the fundamental building blocks of matter and the interactions between them. It involves the use of powerful tools like accelerators and detectors to explore the properties of particles and understand their behavior. Particle physics has led to many important discoveries and has practical applications in fields like medicine and energy.